All right, y'all. Hello again for our first official calculus lesson. We're finally going to dive into the world of limits today. So we did talk about limits a little bit yesterday on the first lesson with instantaneous rate of change and how the limit, as my delta t approached zero, my average rate of change began to approach my instantaneous rate of change. So today we're going to talk about limits on a graph, also some numeric values of limits. Okay, so I'm going to start off right here, kind of talking about the definition of a limit and three different types of limits that we will encounter today. Okay, so the first type of limit that we're going to talk about is a right-hand limit. Okay, and I'm going to go ahead and write the notation here. Okay, so anytime we're talking about limit, you're going to see LIM. Hold on, that's like a little too thick for me. LIM, okay, lim it. Okay, so just LIM. Okay, and you want to write it a little bit higher because we're going to be writing some stuff underneath that LIM. Okay, so we're going to say the limit, and it's always going to be x that's approaching some numerical value. Okay, normally there will be a number in there, but since today we're just doing an example of the notation, I'm going to go ahead and put the letter A. Okay, so x is approaching some value A. Now, since this is a right-hand limit, we're approaching this value A from the right side of the graph. Okay, so the right side of the graph is the positive side. So I'm going to put this little plus sign next to my A value or whatever number goes there. Okay, so this is the limit as x approaches A from the right. Okay, we always want to make sure we know what function we're talking about. So I'm going to write f of x in there too, and it will equal some value. We'll talk about that in a second. Okay, so if I was going to say this out loud, I would say the limit of f of x, okay, the limit of f of x, as x approaches A from the right. That's what that little plus sign is, and then we would have some answer for what it is. Okay, cool. Okay, so that's a limit as x approaches A from the right. Again, I'll talk a little bit more about what this means in a second. This is just some notation. Okay, we have a right-handed limit, so we're also going to have a left-hand limit. Okay, it's really similar. So instead of coming from the right side, from the positive direction, we're going to come from the left side. Okay, so it's really similar notation. So we're going to have the limit. X is still approaching whatever value, A, but instead of coming from the right, the positive side, we're coming from the left, the negative side of a graph. So, oops, not erase. So I'm going to put a little negative sign there. That notates that we're approaching from the left. And we got to name our function. Okay, so if I was going to say this, I would say the limit as f of x as x approaches A from the left this time is some value. Okay, great. So I can have a limit as x approaches whatever value from the right, and I can have a limit as x approaches whatever value from the left. Okay, if they agree, if they're approaching the same value, I say that my limit exists, my general limit exists. Okay, so a little bit of notation here. We're going to have the limit as x approaches whatever value. We're not just focusing on the left, or we're not just focusing on the right. I'm just talking about as x approaches A in general. So no little marking next to the A. We'll just put our f of x. Okay, so this is the one we're going to be dealing with most often. Okay, and we would say the limit of f of x as x approaches A is whatever value. Okay, cool. So this is just a little bit of notation that we're going to need to understand before we can jump into the lesson. Okay, So it says, let's begin our discussion by analyzing this graph in example 1. Okay, now if you were actually in class today, this is what we did for our warm up at the beginning of class. So I am going to go through this just a little bit quickly, just to not waste so much time. Get my little cheat sheet up here. Okay, whoa. So first thing they wanted us to do was to factor and simplify this function. Okay, so if I factor the numerator, that's going to factor out to be 3x plus 1 times x minus 3. And if I factor that denominator, difference of 2 squares, I'm going to have x plus 3 times x minus 3. Okay, and they wanted me to simplify. I can cancel from the top and bottom, x minus 3, and I'm left with 3x plus 1 over x plus 3. Okay, I factored and I simplified my function. Okay, now the fact that I was able to cancel out this x minus 3, that's a removable discontinuity. I just removed that from my function. Okay, so if I take that and solve for x, I'm getting x equals 3. If I go look at x equals 3, there's a hole. Part of my function was removed. Okay, this was my removable discontinuity. So anytime you can cancel something from the numerator and the denominator of a function, there's going to be a hole there. Okay, so x coordinate of my hole, I know it's at x equals 3, and the y value looks to kind of be like 1.75, maybe a little estimate there. Okay, so next they want us to state the domain of the function. All right, so I'm going to use interval notation here. Domain is my x values. Which x values can I plug into the function and receive an output? Okay, so I have this arrow, so I know I'm starting all the way over here at negative infinity. And I'm going along the x-axis, I'm going along, and I reach this vertical asymptote right here at x equals negative 3. Okay, so if I plugged in negative 3 to that function, I'm not going to get a valid input. The domain does not exist at negative 3. Okay, but then I can keep going, keep going, keep going. And then again at positive 3, there's a hole there. If I try and plug positive 3 into this equation, I'm not going to get a valid output. Okay, positive 3 is not a part of my domain. But then I keep going and going forever and ever to infinity and beyond. Cool. Okay, now they want to talk about range. That's my y values. Which y values exist? What am I getting output for? Okay, so I'm going to start at the bottom of my graph at negative infinity. Okay, and I'm going up, 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 up. And it looks like at wherever that hole is, we said y was about 1.75. There's nothing I could plug in to this equation that's going to give me an output of 1.75. Okay, so that's not a part of my range. It's not an output I'm ever going to get from this function. Okay, so I keep going up, 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 and it looks like I have a horizontal asymptote at y equals positive 3. Okay, I'm never going to get positive 3 as an output for this function. And then after that, I go up to infinity. Okay. So this is where we're going to kind of explore the idea of a limit. Okay, I think we're going to use the same graph on this next page. Yep, here it is again. Okay, so I really want to focus in at this point here, x equals negative 3. Okay, first of all, if I asked you, or sorry, x equals positive 3. If I asked you, what is f of 3 here? If I were to plug in 3, what is the y value? There's not one, there's a hole there. Okay, so f of 3 does not exist. There is no value, there's no output if I plug 3 into this equation. Okay, but now let's talk about the limit as x approaches 3. Okay, so I'm going to skip a couple of these and I'm going to come right here. We're talking about as x approaches 3 from the left and from the right. Okay, so let's go take a look at our picture. Okay, the first thing we want to talk about is my left-hand limit as x approaches 3 from the left. Okay, so here's 3, and what I'm going to do is I don't want to start all the way at the left-hand side of my graph. That's not near 3. I want to hang out in the neighborhood kind of near 3. So maybe I'll start here at 2, and I'm approaching the x value of 3. Okay, now as x approaches 3, what is y approaching? What am I getting really, really close to? It looks like maybe 1.75 or 1.8 or whatever you think. Okay, so as x approaches 3, f of x is approaching 1.75. Am I ever going to actually reach 1.75? No, there's a hole there. 1.75 was not part of my range. 3 was not part of my domain. I'm never going to actually reach there. Just like yesterday when we were talking about instantaneous rate of change. My delta t was getting really, really, really close to 0, but it was never actually 0. Same idea here. As x approaches 3 from the left, my y value, f of x, approaches 1.75. Okay, so I can write my limit notation here. The limit as x approaches 3 from the left, from the negative side, for my function is 1.75. Okay, now we want to talk about as x approaches 3 from the right. So I'll go back to my picture. Again, I want to hang out in the neighborhood of where x equals 3 is. Okay, so I'm coming from the right side of 3. So look at 3, now look a little bit to the right. Okay, and I want my x values to approach x equals 3. So I'm getting closer and closer to that dot. And the limit wants to know, what y value am I getting close to? Again, I'm getting really close to that hole that looks to be about at 1.75. Awesome. Okay, so I can say here that the limit as x approaches 3 from the right of f of x is 1.75. Okay, so when my left hand limit and my right hand limit give me the exact same answer, then that means that my limit exists. Okay, so coming back up here, I can use the notation for my general limit. The limit as x approaches 3, just in general, for my function, I'm going to say is 1.75. Okay, so it does not matter that there was a hole there. The limit can still exist. Even though the function does not exist at 3, the limit does exist at 3. Okay, I'm never actually reaching 3. I'm just getting really, 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 really close. Okay, so these are two distinct things. I want to make sure we understand the difference between. You're going to need to know that for tonight's homework. Okay, so let's do a couple more of these examples. Let's talk about as x is approaching -3 from the left and from the right. Okay, so right here is x equals -3. And I want to talk about what's going on from the left and from the right. Okay, so I'll use blue this time. So again, I want to kind of hang out in the neighborhood of x equals -3. I don't want to be looking all over the graph. Okay, so first I'm going to come from the left. So I'm looking at -3, and I'm going to move my eyes a little bit to the left of that. Okay, so here's my function. I'm approaching -3, and I'm going up, up, up forever and ever. What y value am I approaching? Well, not really one specific y value. I'm just going up and up forever and ever. Okay, but I'm going up. That tells me something. So from the left, as I approach -3, my f of x approaches positive infinity. Okay, if I'm coming from the right, so I'm looking at -3, I'm going to move my eyes a little bit to the right. Okay, my function is approaching -3. I'm getting so close. And it looks like my y values are going down, 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 down forever and ever. Okay, so here I can say that f of x is approaching -infinity. Cool. So let's write some limit notation here. Okay, for that top one, the limit as x approaches -3 from the right, from the positive side, plus sign. Okay, we said that was -infinity. And then down below, the the limit as x approaches -3 from the left on my function, we said was positive infinity. Okay, now check it out. For one side, I had negative infinity. One side, I had positive infinity. I'm going in two different directions. My left and right limits do not agree. So I could say that in general, my general limit as x approaches -3 does not exist, DNE. Again, in order for a limit to exist, the left and right hand limits have to be exactly the same. If they're not the same, the limit does not exist. Okay. We can also have limits as x approaches positive or negative infinity. So I'm going to clear off my graph a little bit here. Okay. So as x approaches negative infinity, so my x values are getting smaller, smaller, smaller. I'm hanging out over here on the left. Okay, what's happening to my y values? It looks like they're approaching that horizontal asymptote at x equals 3. Now, is my function ever going to reach 3? No, and that's okay. I don't have to reach 3. A limit is just talking about what we're getting really, really close to. Okay, so the limit as x approaches negative infinity on my function is positive 3. All right, and then we can have x approaching positive infinity over here on the right. Okay, so my graph is moving to the right, my x values are getting bigger and bigger, and my y values are approaching that same horizontal asymptote at 3. The limit as x approaches infinity equals 3. Cool. Okay, so down here at the bottom it says, can you explain what the value of a limit represents in terms of the graph? Okay, so think about the two that we just did. Our answer was positive 3. What was positive 3? Where did we get that from? That was that asymptote. Okay, so as x approaches infinity, or as x approaches negative infinity, my function is approaching some y value. That y value is gonna be the limit. Okay, so what the value of the limit represents? The limit value represents, this is so important, the y value that the function approaches. That the function approaches. Okay, so anytime you are solving for a limit, especially when you're looking at the graph, I mean, anytime, but mostly when you're looking at the graph is when you want to remember your limit value, your answer to your limit should always be the y value that you're approaching. Okay. So this next page, this is actually a page that I'm assigning for homework. At the end of the video, I'm going to come back and do a couple of these examples. So if you're struggling with the homework and you're here to kind of like remember the lesson, either stick around, fast forward to the end, whatever. I'm going to go over just a couple of these. All right, but I do want to talk about this example, when limits can fail to exist. Okay, there are 3 main situations where this can happen. Okay, case 1, so this is a type of discontinuity here. This is not removable discontinuity. We call this jump discontinuity. I've also heard it be called step discontinuity, same thing. All right, so they say justify why the limit does not exist at x equals -1. Okay, so I'm looking right here at x equals -1. And remember, I don't want to be looking all over the graph. I want to kind of hang out in this neighborhood of -1. All right, so let's look at our left hand limit and our right hand limit and see if they agree. Okay, so I've got the limit as x approaches -1. Let's start from the left. Okay, so I'm looking at x equals -1. I'm going to move my eyes a little bit to the left. Okay, here I am. And my x values are getting close to -1. I'm approaching -1 for this function. And the limit asks, what y value am I getting close to? I'm getting close to -1. Okay, then we want to look at our limit as x approaches -1 from the right. Okay, so I'm looking at -1. I'm going to move my eyes a little bit to the right. Here I am. And my x values are going to get close to -1. Here I am. And what y value am I approaching? Now I'm approaching +1. Okay, so right here, when my left and right hand limits do not agree, do not agree. Brownie face. That means that my limit does not exist. Okay, so I can say the limit as x approaches -1, the general limit, does not exist, DNE. Okay, because the left and right hand limits don't agree. Okay, so this is one of the most common ways that we will see a limit doesn't exist when there's jump discontinuity. Okay, again, I don't care about if the function exists there. Whether or not there was a filled in dot at one of the spots does not matter. I don't really care what's going on at -1. I want to know what's going on when we're approaching -1 from the left and from the right. Okay, it needs to meet up. If they don't meet up, it doesn't exist. Okay, it was kind of like this one with the vertical asymptote. One was going up, one was going down. They don't agree. Okay, next sort of thing that can happen for a limit to not exist. Now, what the heck is going on here at x equals 0? Can we tell if we're approaching 1 or a -1? It looks like a scribbly zigzag. Okay, we call this an oscillating function. Okay, even if you were to plug this into Desmos and zoom in a lot to x equals 0, it would still look like this ugly zigzag function. Okay, anytime you have an oscillating function, the limit will not exist at the spot it's oscillating. Okay, for this example, the limit would exist at 1 and 2 and -1 and -2. Nothing crazy is going on there. But at x equals 0, I cannot tell you what's going on there. It is not clear. The limit does not exist. All right, and the third case where a limit does not exist is kind of a special case. Okay, I'm going to call this a boundless function. Okay, so what's going on here as x approaches 2? So here I am at x equals 2. So let's see what's going on from the left. So I'm looking here in this neighborhood. I'm at x equals 2. I'm going to move my eyes just a little bit to the left. And it looks like my function is going up, 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 up. Okay, but a limit always asks, what y value am I approaching? Well, I know I'm approaching infinity. Same on the right. So I can say the limit as x approaches 2 is infinity. Okay, I'm going up to infinity on the left and on the right. They agree, they're going the same way. But how do you approach infinity? What y value is that? Is that a y value? No. Okay, so this actually sparked some debate up in the mathematician world. When I was in university getting my math degree, my professor even said this is one of the biggest debates that mathematicians have. It is about a 50-50 split as to whether the answer to this question would be the limit equals infinity or the limit as x approaches 2 does not exist, because it begs the question, how do you approach infinity? Will we ever get anywhere near infinity? Okay, so really both of these, oh, what the heck was that? There we go. Both of these answers, both are accepted. Okay, if you're taking the AP test, accepted. Sorry, I cannot spell. Okay, if you're taking the AP test and you put the top answer or you put the bottom answer, they would accept both of those. I guess Jean Adams, who wrote this notes page, says that she thinks this does not exist. Personally, I like to say infinity just because it's not like I don't know anything about what's going on. it's going up. That tells me something. Okay, but you could say that my limit approaches infinity. You could say that it doesn't exist. Either answer is acceptable. Okay, so these are the three cases where limits would not exist. Like I said, this first one, the jump discontinuity, is the one we're going to see most often. Okay, so one last page I want to talk about today. Okay, this is estimating limit values from a table. Okay, you might see something like this on Friday's quiz. I didn't say that in class, so if you're watching this, you know something that the people don't know. All right, so if you wanted to, you could plug all this stuff into the calculator yourself, but that's kind of a lot of time to do that. So I just went ahead and put the values in there. Okay, but let me talk about this a little bit. It says consider the function x minus 3 over x squared plus 2x minus 15. Complete the table below to find the limit as x approaches 3. Okay, so I want to know what's happening on this function when x is near 3. Okay, so you might think, all right, well, let me just plug in 3 and see what we get. Okay, so if I plugged in 3 to this equation, on top I would get 3 minus 3 over 9 plus 6 minus 15. And if I work that out, I'm getting 0 over 0. Okay, never write equals 0 over 0 on your paper. If an AP scorer sees that on your test, they're going to take your points away. 0 over 0 is not a real thing. I never want to see you guys say this equals 0 over 0. What the heck does that mean? Okay, so whenever I have 0 over 0 on my paper, I just change it to say, oh no, because I've encountered an issue. Okay, 0 over 0 is not allowed on anyone's paper. You can write, oh no, that's fine. There's an issue. Okay, that's why I have does not exist here. Okay, so it looks like there's like a hole or maybe an asymptote going on. Must be an asymptote. I don't know. I didn't look at the picture. Okay, so basically I want to see what's going on near x equals 3. So I plugged in all 6 of these values that are in the neighborhood of x equals 3. Okay, so let's see what's happening as I approach 3 from the left, from the smaller numbers. Okay, so I plugged in 2.9 and I was at 1.26. I plugged in 2.99, 0.125, 1. I plugged in 2.999, I got 0.12501. Okay, so it looks like I'm approaching some value. I'm getting closer and closer to, it looks like 0.125. Okay, so from the table, I'm able to see what my limit from the left is. Okay, now let's look at the limit from the right. Okay, so I want to start kind of far away, but in the neighborhood and approach 3. Okay, so I started off, I was at 0.1234, 6. Then I got a little bit closer, 0.1248. Then I got a little bit closer, 0.1249. So it looks like from the right, I'm also approaching 0.125. Okay, so if my left hand and my right hand limits agree, then in general, I can say that the limit is 0.125. Okay, it did not matter that there was a hole there. I don't care what's happening at x equals 3. Limits are all about what's happening near x equals 3, in that neighborhood as I'm approaching x equals 3. Okay, even if there was a filled in dot somewhere else on the graph, again, I don't care what's going on at x equals 3. I care about what's happening near and around it. Okay, so this is just like a little picture or whatever. You can read that if you want. All right, so this is the big idea of what we talked about today. Okay, the limit existence theorem. It says that the limit as x approaches some value, c, exists if and only if the limit as x approaches c from the left equals the limit as x approaches c from the right. Okay, if my left and right hand limits don't agree, the limit in general does not exist. Okay, so there is one more page here. This is also going to be part of your homework assignment for today. So it's page 7 and page 10. I want to go and talk about page 7 a little bit. Okay, like I said, I wasn't going over this in class, so if you're here, you're getting a little something extra. All right, so it says consider the function shown on the right. Say that you want to find the limit as x approaches 4 from the right. That indicates a right hand limit. Okay, we're going from the right, not to the right. Okay, so there's a couple here I want to pick out. Let's talk about what's going on at x equals 2. So that'll be here, that'll be here, that'll be here, and here. Okay, so I'm going to talk about A, D, E, and K. So I'm focusing right here at x equals 2. Okay, so the first thing that's being asked, part A, is what is f of 2? Okay, so I'm going to go to x equals 2. Now, this is like an algebra 1 question. This has nothing to do with calculus. I want to know if I plugged in 2 to this equation, what output would I get? Another way to think about it is, where is the filled in dot? It's right here. Okay, remember all of your answers here should be y values. So what's the y value of this filled in dot? It's -1. Okay, again, this question, this part A, had absolutely nothing to do with calculus. This was an algebra 1 question. Okay, it's not even going to affect my later on calculus answers. Okay, this is its own separate thing. Okay, let's go to part D. Now they want to know the limit calculus as x approaches 2 from the right. Okay, so here I am at x equals 2. I'm looking in this neighborhood. I don't care about what's going on over here. I don't care about what's going on over here. Okay, so I'm coming from the right. So I'm going to look at x equals 2 and move my eyes a little bit to the right. I'll start over here. Okay, and I'm approaching x equals 2. I'm getting really close to that x value. And I want to ask myself, what y value am I approaching? I'm getting really close to this hole at y equals +1. Cool. All right. Part E is asking for the limit as x approaches 2 from the left. Okay, so again, I'm looking in this neighborhood. I'm looking at x equals 2, and I'm going to move my eyes a little bit to the left. I'll start right here. And as my x values get closer and closer to 2, what is that y value that I'm approaching? Looks like it's right here at that filled in dot at -1. Okay, it doesn't matter that there is a filled in dot there. There could have been a hole, there could have been a filled in dot. Either way, I'm getting close to that y value of -1. Whether or not I actually approach it, doesn't matter. Okay, so now in part K, they're asking for the general limit as x approaches 2. Remember, a limit only exists if the left hand and the right hand sides agree. Okay, so here I said that from the left, I was approaching -1, and from the right, I was approaching +1. So this limit does not exist. I don't meet up at the same spot. Okay, so here I can say the limit does not exist. Cool. All right, so I want to talk about just a couple more. Let's talk about what's going on at -1. So B, G, F, and J. Okay, so here at B, they're just asking algebra 1 question. What is f of -1? Where's my filled in dot? Here it is at 4. Again, this has absolutely nothing to do with my limit. This is just an algebra 1 question. Okay, now let's talk about as I'm approaching -1 from the left and from the right. Okay, so here I am in my neighborhood of -1, x equals -1. So from the left, looks like I'm getting really close to a y value of 2. And from the right, looks like I'm also getting really close to that y value of 2. My arrows are matching up. Okay, so the limit from the right is 2. The limit from the left is 2. And since they agree, that general limit is also 2. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. All right, I did more than half for you, so you're welcome. Thank you for watching my video. Yeah, I guess that's where I'm going to go ahead and end it. Okay, so you're going to want to finish this page that's numbered page 7, and also the last page that's numbered page 10. Okay, you can submit that in the Schoology Dropbox for me. I did hear some people were having an issue printing their notes to PDF. If that's you, you can take a snip and submit that. That's fine. Just let me see your homework. However you submit it is fine by me. Just let me see it. Hey, if you have any questions, like always, shoot me an email, hit me up in class, text me on Remind. However, I'm here to help you guys. Okay, tomorrow we'll continue talking about limits. I think we're going to talk about properties of limits tomorrow, so get to know them a little bit more. Okay, hope you guys have a great day, and I will see you later.